Hello everyone, in this video I'm going to show how to compare linear and log transformed regression models using R. First, let's check our data. You see the rental data for Ann Arbor, Michigan, which is home to the main campus of the University of Michigan. The data include the monthly rent, which is in dollars, the number of bedrooms, the number of bathrooms, and the square footage for 40 rentals. First, we are going to set our working directory in R, and then we import the data, which in this case our data is Ann Arbor.csv. And then we have here, as you see, 4 different models. The first one is a multiple linear regression model. Rent is our response variable and the remaining variables are our predictor variables. Model 2 is a logarithmic model in which the square feet is in log transformed. Model 3 is an exponential model in which the response variable is log transformed. Model 4 is the mixture of both models. You have rent log transformed and square feet log transformed. To get the summary results for each model, we need to use the summary function. Summary model 1, control enter, and adjusted R-square is 0.79. So we are going to use adjusted R-square to choose the best model. And for model 2, control enter, adjusted R-square is 0.8355. For model 3, adjusted R-square is 0.7937. And for model 4, adjusted R-square is 0.8497. Therefore, fourth model seems like the best model. We then generate predicted values for model 4 or logarithmic rent using the predict function. Within the function, we indicate the name of the model or object. We label predicted rent as pred_ln rent. So let's type predict pred_ln rent is equal to predict model 4 and control enter. Next, we want to calculate the predicted values for rent, not a logarithmic rent, which in this case we are going to use a formula, and we label this new predicted rent as pred_rent. So in order to get the predicted rent, we need to transform back to logarithmic rent that is predicted by the model. For that reason, we need to use the standard error of the model, which is provided by the summary statistics, which in this case, summary statistics, as you see on the screen, 0.1262 is the standard error. We could use the standard error of this estimate, which is provided by the model summary output. However, we first obtain the unrounded value, which provides a more precise estimate, and we label this value as standard error. So first, before we predict the rent, we are going to get SE summary model 4 and $sign sigma, and then control enter. Now you see the unrounded version of standard error under the environments pane. And now we can use to transform back predicted logarithmic rent to predicted rent. Pred_rent is equal to exp for exponential function pred_ln rent plus se to the power 2 divided by 2, and then control enter. Finally, we use R's core function to calculate the correlation between rent and predicted rent. We square this value to find the coefficient of determination R-square. So we are going to enter here core, and then my data $sign rent, and then predicted rent. We are going to square this data to get correlation coefficient. So based on this result, we can say that model 2 is better than model 4, because when we transform the predicted logarithmic rent and find the correlation between rent and predicted rent, we find an R-squared 0.76, which is lower than the model 2 R-squared. So for that reason, model 2 is the best model for this data. This is how you compare linear models and log transform models and choose the best model using R. Thank you for watching.